Most AI agents fail catastrophically after just a few turns. Context windows fill up, state drifts, hallucinated actions pile up, and suddenly your multi-hour workflow is completely bricked. But what if an AI agent could operate across desktop GUIs and terminals for dozens of hours with zero state drift? Enter LongHorizon-Harness, an open-source state management and execution engine designed specifically to keep complex, long-running agent workflows on track without losing context or progress.
LongHorizon-Harness is not another standalone model or proprietary framework. Instead, it sits directly on top of agent backends you already use, including Anthropic's Claude Code and OpenAI's Codex. By wrapping execution inside a resilient harness, it coordinates complex tasks across web browsers, desktop applications, design tools, and command-line terminals. The result is continuous multi-hour execution where goals, state evidence, and verified outputs remain strictly consistent throughout.
The core innovation here is the tri-role architecture: manager, executor, and auditor. Instead of burdening a single agent with planning, tool usage, and verification, LongHorizon-Harness splits responsibilities. The manager maintains the high-level roadmap. The executor starts every single round with a completely fresh context window focused on one task. Finally, an independent auditor inspects files, system logs, and UI components in the live environment before any step is officially added to verified state.
Let's look at how the model client layer is structured in the codebase. Inside model_client.py, we see a clean facade pattern that abstracts LLM calls across OpenAI, Anthropic, Bedrock, and Gemini backends. This decoupling allows developers to assign different models or backends to each of the three roles. For instance, you can use a fast reasoning model for planning, a specialized coding agent for execution, and a strict vision model for visual UI auditing, optimizing both speed and operational costs.
The empirical benchmark gains are massive across real-world workloads. On Weavebench, which tests complex hybrid tasks across GUI and CLI environments, completion rates jumped from roughly 50% to over 80% using identical model backbones. On OSWorld 2.0, full desktop task completion tripled. And on TerminalBench 2.1, task success jumped by 7.5% while actually consuming 24% fewer tokens due to fresh context execution strategies.
Taking a deep dive into the experiment runner code in lib_run_single.py, we see how durable checkpointing and atomic result persistence work under the hood. Every evaluation result is persisted alongside structured JSON metadata and step checkpoints. If an agent hallucinated an invalid action or an auditor check fails, the harness prevents bad state from corrupting the task history. It simply rolls back the executor while retaining all previously verified milestone progress.
LongHorizon-Harness is completely open source under the MIT license, hit #1 on Hugging Face daily papers, and is super easy to get started with. You can install it using UV tool install LH-Harness, initialize a project config, launch the interactive web dashboard, and run LongHorizon tasks across Claude Code or Codex instantly. Make sure to star the repository on GitHub, hit that subscribe button for more deep dives into open source AI tech, and let us know your thoughts in the comments below.